Hello, I'm Professor John Baugh, and this is CIS 2252 C++ programming. First things first, we need to go over where we'll have most of our content. Now, if you're watching this, you probably already found Desire to Learn. I will send an email just to make sure that everyone knows how to get into it, but we'll go over how to get into Desire to Learn if you're new to it. First of all, you're going to go to Internet Explorer or Firefox or your browser of choice, and you go to oaklandcc.edu, which is the main page for Oakland Community College, and then you're going to go under Distance Learning, then click Login to Desire to Learn, and then put your username and password that you have for your Oakland Community College account. Then you're going to click under the appropriate course. In this case, it'll be Object-Oriented Programming C++. We click there, and this is where we'll have all of our discussions. All of the course materials will be uploaded to here, and where you'll have all your assignments. So without further ado, let's look at the syllabus. For you to get a copy of the syllabus, it's in PDF format. Notice under the content browser you have currently the folder Syllabus and the Session 1 folder. You need to click the Syllabus folder. Notice to get back to the other folders you can click Home. Right? Same thing with Session 1. Click that and then click Home to go back. So under Syllabus we have the syllabus that you can download, and I already have it. So we'll briefly go over this. This is CIS 2252, Object-Oriented Programming of C++. This is Oakland Community College, and although it won't affect you very much, this is the Orchard Ridge campus that I'm recording from, and this is for the summer 2013 session. Generally there's a meeting time for courses. However, the way this online course will be structured, you won't have to have a specific meeting time except for one of the tests, which we'll talk about. The course will be held online, and I will typically upload the course material early in the week that the lecture is scheduled for, or even earlier. For example, right now I'm recording this on May the 1st, and the class doesn't actually officially start. The course doesn't start until May 6th. So we'll say that Monday or Tuesday you should have all the material ready for you to read or to watch. My name's John Philip Baugh, and I hold a master's degree in computer science from the University of Michigan at Dearborn, and I'm currently working on a PhD in information systems engineering, and I've taught for nearly a decade now in various capacities. I've taught at the University of Michigan Dearborn as an adjunct since about 2005. Slightly earlier than that, I was a lab assistant as well, and I instructed in the beginning C++ and intermediate C++ courses that they have there. In addition to that, I've taught game programming, Visual Basic, Java, C++, Microsoft Office, computer networking, both at undergrad and graduate levels at the university. And I teach C# here. I'm teaching a mobile development course in Android development in the fall, and a host of other courses. So I have quite a bit of teaching experience, and I really enjoy it, and I'm very glad that I was given the opportunity to be a full-time instructor here at Oakland Community College. Prior to becoming a full-time faculty member here at Oakland Community College, I was a software engineer at Siemens PLM Software in Ann Arbor, where I worked from the graduation with my master's degree in 2007 up until 2011. So I've been here at Oakland Community College since August of 2011. So I've been teaching courses since the fall. I was actually an adjunct. I taught one course over at the Royal Oak campus while I was awaiting to see if I would get the position, full-time position here. That was in JavaScript. Okay, so my office is room F117, and I'm in here occasionally, but over the summer I'm in here less frequently. During the fall and winter I'm here quite frequently, but for your purposes, if you need to visit me, just email me and make sure that I'll be in. But regardless, I'll have virtual office hours and I'll stay close to my email, and possibly we'll use Adobe Connect or Skype or something if you need something a little more intense. We will try to use that, or possibly the messenger that is available through Desire to Learn. But we will definitely work out something so that I can explain to you how to do something if you're having trouble and give you examples. So in general, I'm reserving the slot Wednesdays 10 a.m. to 12:30 p.m., but to be honest, I check my mail quite frequently, several times a day, so you're fine if you're just emailing me at 4 in the morning. I might be getting home from Buffalo Wild Wings, or something like that, so it'll be quite possible that I'll still be up working on side projects or grading or things like that. So just email me whenever you have trouble, and I'll try to get to you as soon as possible. The email that you'll be contacting me at is jpbaugh@oaklandcc.edu. All right, and for the course objectives, students should have a basic understanding of general programming concepts and techniques prior to enrolling in the class. Students will be instructed in the syntax and semantics of ANSI C++ language. Topics covered include control structures, arrays, pointers, strings, dynamic memory management, class definition, and object-based development, file input-output, overloading, exception handling, and template libraries. Students will be required to complete computer-based assignments inside and outside of class. Now, the first part might be a little, might make you a little bit nervous if you've had no programming experience whatsoever. Don't worry, this is just the official course objective statement. If you don't have any programming abilities or experience whatsoever, then it's okay. As long as you know how to use a computer. Now that I do expect. If you smack the mouse upside down or use whiteout on your monitor to correct errors in your Word documents, then you probably need to take CIS 1050 first. I know that enrolling in this course, most of you probably have at least basic familiarity with computers. You should at least know how to do basic word processing, use the internet, and internet applications such as the web. Some of you probably have experience playing games online or using instant messaging software. Some of you have experience with mobile technologies. So most of you are probably well acquainted with computers. But if you don't have a fundamental understanding of computers and how to use them efficiently, how to do file management, if I give you a flash drive, you should be able to plug it in and then download a file to it from a website or take a file off of it. This seems very simple to some of you who are listening to this, but to some people it's very difficult. So anyway, if you have any troubles or any questions about requirements for the course, just contact me, but these are pretty straightforward. And this is not a hard requirement right here. Okay, so again, it gives a prerequisite. It says students should have a basic understanding of general programming concepts. That's, again, not necessarily true. For the textbook, we will be using, mostly for reference and sometimes for the slides, C++ How to Program, the 9th edition by Didle and Didle. It's a Pearson publication. The technical copyright on it is 2014, and I give the ISBN on here. You can acquire it from the bookstore here on campus or from a bookseller near you, such as Barnes & Noble, or even from Amazon.com or other companies. Half.com if you're looking for an alternative, but since it's a new edition, you may not be able to find a used copy. It's brand new, so I apologize for that. The topics covered in the course are basic computer architecture, introductory programming concepts, classes and objects, strings, control structures, functions, pointers, templates, file processing, and the standard template library, or the STL. So the website for the course. Supplementary information will be available via Desire to Learn, also known as D2L around here. So if you hear me say D2L or Desire to Learn, I'm talking about the same thing. It's a learning management system. So if you're familiar with Blackboard or possibly Canvas or another learning management system like that, Desire to Learn is a learning management system. In my opinion, having experienced homegrown learning management systems like they use at U of M Dearborn, and also having used Blackboard extensively, Desire to Learn is significantly better, in my opinion. It still has some small bugs here and there and problems, but that's to be expected with such an enormous learning management system. When you log into Desire to Learn, you go to oaklandcc.edu. Again, you put in your username and password, and then click login, and you should be able to click the name of the course over to the side, and then you'll see all the course material. Again, the content browser, news will be where I'll put news items and other information, and then there's CIS student resources that pops up here. It gives the times and information for the various campuses' computer labs if you need to use their labs, and also gives information for where tutors will be. Okay, so there's also a calendar and also updates if anything's been updated for the course. So the next thing is you will have PowerPoint slides that will be uploaded. We may or may not go through them very thoroughly. The titles tend to have a significant number of slides, and it's usually a little bit overdoing it. I might use it while I'm lecturing on particular topics, just as a placeholder and a reminder of where we're going. I'll probably skip over several slides, so don't worry if you see a set of slides that's like 200 slides, that thinking you'll be here for 7 hours watching material. It's not the case. There's also going to be supplemental materials in some cases. I'll write out supplemental materials which kind of summarizes various chapters. There will also be links to the lecture recordings, class announcements, course syllabus, test dates, handouts, and other information. For email, all students are requested to obtain an email account. If you have any questions about the course or need assistance, please contact me by email and I will respond as quickly as possible. Okay, how do I grade? Well, I don't use a percentage scale, a direct percentage scale, like some instructors do. I use a straight point scale. So the homework and miscellaneous, this one is the one that varies. You may get one homework assignment throughout the semester, one just homework assignment. You may get 2, you may get 10. It's basically at my leisure, but I will probably just give you one or two, maybe a few more just to enforce topics. They will usually be very simple, just for something for you to complete, and there may be special topics that are worth varying amounts. It may not just be 20. But we will also have a midterm examination, 100 points. Your first programming project is 100 points, your second is 125, third is 125, and your capstone project is 200 points. So basically you have one examination and 4 projects. The one examination is the midterm. There is no final exam. Okay, so I know that makes a lot of you pretty happy. Now, here's my grading scale. You can look at it at your leisure, but basically an A is 95 to 100, and it goes all the way down to D's and F's. So the official grading system does not allow me to put in a D minus, so actually that's incorrect. So 60 to 65% is a D, essentially. When it comes down to the end, if you end up with, for example, 94.7%, I will generally bump that up to an A. I'm going to do everything in my power to ensure that everyone gets the best grade possible given what effort they put in to the course and what they did. Projects and homework. Again, I will assign homework and programming projects to test and enhance your abilities as programmers and software developers utilizing the C++ programming language. Okay, for submitting homework and the late penalties associated with them, you will generally be submitting a compressed, meaning zip or RAR version of your completed assignment to Desire to Learn under the appropriate folder in the Dropbox. So right here is the Dropbox. You click Dropbox, and this will have a list of particular items that you'll have to do. So as a matter of fact, right now I'm going to add an assignment, a very small assignment. It's going to be called Introduce Yourself. It's going to be out of 5 points under Assignments, and Introduce Yourself. 5 points. Okay. So save it. Oh, already created it. Okay. Never mind then. I will see why it's not showing. Okay. Right. Again, Dropbox will have all of the information in it that you'll need for all of your assignments. Anything you need to do for class will be under Dropbox. So that's basically just a straightforward analysis. The other thing, just give me a second here. And I'm gonna do these lectures basically the same way that I do for. I'm gonna make this course active too. Basically, the way I would do it in class. So if you see me, tripping over my words and stuff like that, that's because I prepared the lecture, but I don't prepare them so much that they're over prepared, and you don't see the mistakes and the stumbling and whatever. So. I'm not sure why that's not showing. Okay, here we are again. Sorry about that. I did take a quick reprieve so I could fix some things. There was something wrong with the assignment here. But anyway, under Dropbox, you'll now notice that there's a discussion board assignment, and basically you click on it, and to you guys it will say, go to the discussion board and introduce yourself, following the listed instructions under topics. So what you'll do is you'll go up here to discussions, and then notice that there's the general discussion format and then an introduce yourself. Your view of this may be slightly different than mine, or significantly different than mine. In fact, I can, let me see here. Okay. Anyway, when you click on here, you should be able to see information in here. They've changed D2L on me, unfortunately, a little bit, so I might be stumbling slightly. Okay, so you go to the discussion board and introduce yourself, following the listed instructions under the topic. So I go to the discussions, and under here I have an introduce yourself. I click that, and then I've already posted an introduction, as you can see. Information about me, so I want all of you to do that. The other thing I want you to do is, if you do not already have a picture, I'd like you to edit your picture under your profile home. You go under My Home, and then you're going to click on Profile, and then you're going to change Picture, and then you just upload a picture and save it. So now what we're going to do here is, we've gone over how to get to D2L in the syllabus, and we've gone over Dropbox. That's where all your assignments will be. I don't want you to send me paper copies or email them or send them by carrier pigeon to my house at 4 in the morning. I don't want any of that. Everything you do is going to be under Dropbox, except for your test, which will most likely be in person. Okay, so we need to go over one thing before we start on the supplemental material, just so I can go over it. But you should have what we call an integrated development environment. Now we'll go over the details of that as we progress through the course, what that is. But just as a note, the integrated development environment we'll use for the course primarily is called Visual Studio 2012. If you have the 2010 version, that should suffice. In fact, since unfortunately they haven't installed it on my machine yet, and I had a miscommunication apparently with them, I have the 2010 version right now, but the 2012 version isn't installed yet. So I'll do a simple example today in 2010, but the instructions are nearly identical for 2012, so it won't be a big deal. But to get a copy of Visual Studio 2012, you need to go to dreamspark.com. DreamSpark is something that Microsoft owns to allow students to download their software for free. So you're going to go under Academic Institutions and then click on Subscription Access right here. Okay, so Academic Institutions, Subscription Access, and then under Find Your Academic Institution, you should be able to type Oakland Community College or Oakland, and it comes up as Oakland Community College, first one. I click that, and then you have to very carefully click Visit the Web Store, and click Continue if there's a dialog. We'll maximize that. It goes to a place called On the Hub. That's where the actual software is hosted. And you should be able to log in and download Microsoft Visual Studio 2012. If it does not let you log in, or it does not let you, or it says you have an invalid password or what have you, then we will, you can email me and I'll try to ensure that you have, for your appropriate email, your Oakland CC email, that you have access to this stuff. It's under Developer Tools. You have Visual Studio 2012, but notice there's also the 2010 version. There's even Microsoft Visual Basic 6, which is old. Connect SDK. There's all kinds of stuff in here. So, tons of free software that you can download as long as you're OCC student. Okay, even the 2008 version of Visual C++. Also, there are operating systems. You can download Microsoft Windows 8 and other stuff from in here. There's other applications, servers. Unfortunately, the full Office is, newer Office is not available in here, but Access and a couple other things are available in here. So that's DreamSpark. All right, so you will need that. Now, if you're, if you are taking a C++ course, which you are, that means that you may not have thought that we would be using Windows technology. Now, if you don't have Windows technology, since C++ is a platform agnostic language in most respects, I'm not requiring you to have, the Visual Studio. If you have Windows, you definitely need to get it. Windows Studio Visual Studio 2012, or 2010 if you have to, but I would rather you have 2012. If you do not have Windows, then there are alternatives. Mac users can download Xcode for free. You basically go to Apple's website and then search for Xcode. Xcode, it's just the letter X, C-O-D-E, and you should be able to download that and ensure that you install the C++ compiler with that. For Linux, there are various C++ IDEs. One of the popular ones is the Eclipse CDT. You can go to eclipse.org. It's the same. It's similar software to that which you've used if you program Java or Android development. Eclipse is used for that as well. Okay, so that's how you get the IDE that we'll need to actually do the programming. Now, the IDE is a set of compiler, debugger, linker, loader, and some visual tools to help your programmer be better. So this is what an IDE looks like. This is the Visual Studio 2010 Professional IDE. In general, when you have no projects open, you may or may not see anything here. I usually keep a Solution Explorer over here and other things, but we'll go over how to create a project in just a little bit. Okay, so back to the syllabus. This is our 16-week tentative course outline. The first day of class is May 6th, week of May 6th, all the way until the last day of class, August the 19th. The last day to drop the course is August 2nd. I would hope that you would have figured out by then whether you should be in the course or not. Also note that the homework, non-project assignments, are not listed on the syllabus, but they will be posted as needed on D2L. So keep an eye on the Dropbox. For example, just like I showed you a second ago when I was having some issues here, Dropbox, there's a discussion board assignment. That is your first assignment. It is worth 5 points, so it isn't nothing. So you're going to go under discussion, basically introduce yourself, and get the 5 points. That's basically all it is. But, you know, have fun with it. Don't make it something boring. Now, the first thing is in the course outline. The first week we're just basically doing an introduction to the course, which is what we're doing now, going over the syllabus and such, and then introduction to C++, which we'll get to in just a minute. Next week we'll go over a little into classes, objects, and strings. Then we'll get into control structures. Then we will do functions the following week, and also review for the midterm. And also I will assign Project 1 that week. The midterm is scheduled for the week of June the 10th. We will go over that, and I'll describe when we're actually going to meet here, when the appropriate times are to meet here to take the midterm. If you are out of state or just can't make it to the midterm, this is an online course after all. We will arrange something, but you have to get it proctored, which means you have to have a designated approved proctor that I will say is okay. It could be a professor or faculty or staff at another college. It could be an employer in some circumstances. You just have to contact me and say, is this person an appropriate proctor for my examination? After that, we'll go for arrays and vectors, then pointers, then go over classes in more depth for a couple weeks. Notice along the side you have another programming assignment assigned on the 17th of June. Then that one's due, and then another one assigned on the 8th of July. Then the capstone project will be assigned on the 22nd. You get several weeks to do that. It's generally more complicated. We'll go through operator overloading on the 15th, inheritance on the 22nd, stream input and output, a deeper look, and more file processing. I might integrate some file processing earlier into here because it is an interesting topic. We'll go over the STL on the 5th, strings, a deeper look, and then on the 19th, that's basically instructor's choice topics. It could be just topics of interest. Since we don't have a final, it's not like any of this directly affects your grade except for possible implications with the capstone project, but I will take questions on that. Another note is the discussion board. I will, you could post under general discussion if you have specific questions. I could post a new topic here, like questions. I might post a topic like questions for Project 1 assignment or something like that. So if you have questions under there, look there frequently. Your friends and peers might be asking the same questions. And if I get enough questions, either through email or through the discussion board, I will perhaps make a short video or small tutorial or some sort of digital help to make sure that you understand how to do it. Okay, so policy on use of computing resources. If you're on campus here, the information technology resources, computers, networks, electronic data, and information are provided by OCC to its faculty, staff, administration, and students in support of the college mission. Users of this information technology resources will abide by applicable federal and state laws and the college's regulation governing the use of these resources, and will use them in support of activities directly related to duties and assignments. So, you know, basically just don't, if you're on campus, if you use the stuff here, don't do anything that's questionable. Don't look up websites you shouldn't be looking up. Okay, naughty websites, hacking websites, downloading stuff that you shouldn't be downloading, stuff that you're getting by pirating, or that could be construed as pornographic or anything like that. So that's basically what goes on there. Policy on plagiarism and cheating. Basically, if I catch you cheating, it's going to be a very, very serious offense. Cheating, if I tell you specifically for an assignment, or most assignments, homework, I don't mind you kind of helping each other if you know someone, or even to an extent getting some help, outside help on the programming projects. But in general, you should be posting stuff to this discussion board and emailing me or otherwise contacting me to ask questions. I don't want you to just have someone else do it for you or do the majority of the work for you, and you sit aside and just smile and nod. You're cheating yourself. You're cheating your classmates out of being honest. Basically, by being dishonest, you're cheating them because they might have worked really hard on it, and you just cheated your way through it. So getting the credit to this course shouldn't be your ultimate goal. If you do your best and you are invested in your own education, you should do fine in the course. So worry about learning. That's very important. You might get a piece of paper when you graduate college that might get you in the door of a company, but your actual knowledge and what you know how to do will keep you in the building. All right, so the paper might get you through the door, the knowledge keeps you in the building. Remember that. So ADA notification, students requiring special assistance, including those affected by the Americans with Disabilities Act, should contact the Access Office and inform the instructor of any special conditions pertaining to their learning. Generally, this isn't a problem for online because you might, as some people need note takers and things like that, but since you have the recorded lecture, you can go back and review it, and I don't mind if you have someone to help you understand the material if you're having problems. But other disabilities, it could include physical disability or mental, emotional disabilities, anything that affects you, keeps you from learning or affects how you learn. I should be made aware of it. If you feel you need special consideration, extra time for tests, things like that, the Access Office is who you need to register with. There's a different Access Office on each campus, so if you do go to Oakland Community College and you are on, say you're registered with the Access Office at Auburn Hills or at Highland Lake or Royal Oak or Southfield, you need to register with the Access Office here at the Orchard Ridge campus in Farmington Hills. Okay, so unfortunately they are separated. I think they're trying to remedy that eventually, but right now it's not remedied. So you need to go to each one that you have classes on. Okay, the next thing is FERPA. FERPA is the Federal Education Rights and Privacy Act. Basically, I am not going to release your personal information, such as your grades or, well, it doesn't really apply to online, but does so-and-so attend class? Do they, frequent the discussion boards? When's the last time they logged in? These are all personal information. Even if you're under 18 and you're taking this course, so legally you're a minor, I still will not tell your parents without written consent from you how you're doing in class, what your grades are, etc. It's really a non-issue as far as what your grades are, because if you want to show them your grades will be under grades in the desire to learn. All of your grades will be online. It's not like I'm keeping some secret book or something where your information is not there. So you have access to your grades all the time. As soon as I grade it, you know what the grade is. Okay, so disclaimer, again, I have the right to change any of the syllabus if I deem that it will help you learn more effectively or it will help you to achieve better. I'm not going to just decide, hey, we're going to have 19 more programming projects out of the blue. It's not going to happen like that. Basically, the disclaimer, so I can ease it, if anything. I can say, oh, well, I know this says that project 1 is due this day, but it seems like everyone had trouble with it, so we're going to put it off for another week or something like that. That gives me the liberty to do this. So by taking this course, you agree to the syllabus and all of the requirements therein. If you have any questions, again, just email me, jpbaugh@oaklandcc.edu. Okay, so that's that for the syllabus. All right. Okay, so the next thing we're going to do is we're going to go over the supplement briefly. I'm just going to use this to kind of guide us for our actual lecture or what have you. You might occasionally see me hit the pause button for Camtasia. That's because I'm taking a drink of water or coughing violently or something like that. So I hope it doesn't alarm anyone. But this supplement for session 1 is available on D2L under the course home. Basically, all you have to do is you go under session 1, and then you'll be able to see the notes. And then I also put the PowerPoint slides for that. I'm not going to be going over the PowerPoint slides for this particular session, but they are available if you want them. Okay, so the next thing is the Session 1 Introduction to Computers and C++ Programming. This is custom written by myself. This is for Class 1 session, and it covers basically chapters 1 and 2 of the class textbook, which is the 9th edition of How to Program by Didle and Didle, and also I give you a basic introduction to C++ and Visual Studio. Okay, first things first. Before we get into programming, we need to be certain that we're on the same page as far as some topics. So computers, for our purposes, are electromechanical devices that process data. Software is made up of instructions that tell the computer to perform a set of tasks. Software is the intangible portion of the computer. In other words, you can't touch it, in regards to MC Hammer. Software is the stuff like the operating system, such as Windows 7 or Windows 8, Mac OS 10, Linux, Red Hat, Ubuntu, etc., and application. That's application software like Microsoft Word, World of Warcraft, Internet Explorer, Rift, StarCraft 2, Visual Studio itself could be considered an application as well. So that's software. That's the intangible stuff. So PDF Reader right now that we're reading this PDF out of is software. It's a piece of software. Hardware is made up of the physical stuff that makes up the computer. So for example, the central processing unit of the computer, the RAM or memory of the computer, the graphics processing unit, the motherboard, etc. The things you can't actually touch. And also other devices, peripheral devices, which means they're connected to the computer from the outside, such as the printer, the monitor, speakers, keyboard, etc. A mouse, these are all hardware because you can actually touch them. In this class, since we're computer scientists, or since we're studying computer science and software engineering, we are concerned with the software aspect more so than the hardware aspect. In this class, we're going to study C++, which is a high-level programming language, so we're primarily focused on software. Computer programs are the sets of instructions that tell the computer how to process data and to perform actions. People who program are called programmers. So this section right here, bits, bytes, and language types. There are 3 general types of programming languages, general categories. There are many, many ways to categorize programming languages, but this is the way to categorize them in terms of their closeness, essentially, to the actual machine code. There's machine language of a computer, assembly languages, and then high-level languages. Computers at their most fundamental level only understand machine languages. These languages are usually quite difficult for humans to read, write, and generally understand. They ultimately consist of zeros and ones, which represent off and on electrical signals, respectively. Okay, so the machine code is dependent on the processor and architecture of the computer that you're on, so we call it machine dependent. Depends on the machine you're on. And it is the only language that the computer understands, are the zeros and ones. So these zeros and ones are known as bits. Okay, bit is short for binary digit bit. Machine languages are machine dependent, which I just said, which means they can only be understood by specific architecture for which they were written. If you have a RISC processor on some IBM machine, it's not going to understand necessarily all of the code or any of the code at machine level that was written for an x86 processor, an x64 processor, or something like that. So back in the day, that was the only way really to program. Okay? Since this was too difficult and tedious, assembly languages were developed. Instead of using the strings of numbers that the computer directly understands, symbolic abbreviations were used to represent fundamental operations. These fundamental operations could consist of things such as load, add, multiply, store, etc. Programs called assemblers convert assembly languages into machine language. So ultimately, the computer needs a machine language. It doesn't understand assembly language. But assembly language is better for us as people to understand because it's closer than machine language is. It's closer to English or a natural language. Another thing is we're going to distinguish between programming languages. If I say language, usually I mean programming language in this course. If I want to refer to something like English or Spanish or German or Urdu or Hindi or what have you, I will say natural language. Okay, these are languages, spoken languages. It's called a natural language. So these assemblers take the code that the programmer writes in assembly language and converts it into machine language. Okay. Although assembly languages did help, they still require programmers to write several lines of code, even for the most fundamental of tasks. The advent of high-level programming languages helped programmers even further. Now a single programming statement could be equal to several statements in an assembly language. High-level languages are generally easier to read, write, and maintain than their assembly and machine language counterparts. Okay, another way to categorize languages, since we do want to know the basic tenets and basic properties of languages in general, because we're studying to be good problem solvers and good computer scientists, not just good with C++. This is why we're going over this. We need to know how to categorize languages. So there are different ways to categorize these languages. Programming languages are often categorized into one or more types: imperative, functional or declarative, logic, and object-oriented. Imperative languages are languages that essentially spell out the instructions for the computer. Like in English grammar, where imperative means making a command, giving advice or instructions, imperative programming language involves telling the computer to do this, then that, etc. Languages like C, which is a predecessor to C++, are imperative and might have a statement like this. Okay, so the above code assigns the value of var2, which is a variable with 6 added to it, into the variable myvar. So myvar is assigned to the value of whatever's in this variable. Maybe it's a 5, maybe it's a 10, maybe it's 100, we don't know, plus 6. So if 100 is inside this var2 variable, 100 plus 6 is 106. That value will go into the variable myvar. Variables are like storage units that contain values. So that's imperative languages. Imperative. You give them instructions, they follow it directly. Functional or declarative languages describe what should be done, but not necessarily how to do it. For example, languages like Lisp and SQL or SQL are functional or declarative. SQL, for instance, would give an example of what the result should look like. So SQL, you say, I want to select all of the items from the books table where an author is named Didle. And then the above code says return all books whose author is Didle. So if I have a huge database, that's what SQL is used for. If I have a database and I say I want it to look like this, I want it to be all the books where the author's name is Didle. Okay, but I'm not telling it search row 1, then row 2, then row 3, then row 4. I'm not instructing it directly how to do this. So that's the difference between this declarative language. I'm declaring what I want, and the language takes care of it. It looks through the database for me. Logic languages are languages that use logical statements in the form of rules. These rule-based languages state facts and do not give a step-by-step set of instructions either. An example of a logic language would be something like Prolog. The above statement in prologue, known as a fact, makes an association between John and Sally, stating that Sally is John's mother. Okay, prologue uses usually a much more complicated, not necessarily complicated, but a much more convoluted, maybe, language that isn't exactly close to something you'd be used to if you've dealt with imperative languages before. Okay, we call this style of language a predicate calculus. All right, sounds complicated, sometimes is. So finally, the fourth category, object-oriented languages, are languages that view programs as a set of interacting objects. Humans are very good at thinking in terms of objects because we interact with them every day. We use what's called abstraction. Okay, we use abstraction, which means you interact with a microwave. You know to press certain buttons on it, but you don't need to have a degree in physics and know how the electrons and everything is bombarding the food inside the microwave in order to make it work. You don't have to be an automotive mechanic to drive a car. You don't have to be a civil engineer to know how to drive across a bridge or to use a bridge. This is all called abstraction. Right? We're good at abstraction. So in an object-oriented programming language, you might program a microwave object, and then once it's tested and confirmed to work, you can create as many microwave objects as you need. Then you can interact with whatever you define them to interact with and do whatever you want them to, and you don't have to concentrate on how they work anymore. So once you have it working, you have a self-contained object that just works, and you tell it, do this, do that, and you don't have to go through the code over and over again to know how it does it. Objects have attributes, which are stuff that describes the object, like weight, height, color, things like that, and behavior, which is the stuff the object can do. Okay, can it print its name? Can it tell me its name? Tell me your weight. What is your weight? What is your height? What is the color? What is the size? What is the texture? You can ask objects questions, basically, and the behavior is what do they do. If I had a dog object that I created, then maybe the dog barks, or maybe the dog can tell me its name. There's all kinds of interesting things that you can do with programming languages. So attributes are more like the nouns describing an object, and behaviors are the verbs of what the describing what the objects can do. Now, to what you've all been waiting for, an intro to C++ programming. We will cover object-oriented programming extensively in this course. C++ is an object-oriented, or more accurately an object-aware programming language. You can write strictly imperative procedural programs using C++. We will do a lot of that, actually. This doesn't leverage much of the object-oriented features of the language, but once we have an understanding of basic syntax, we will quickly begin to use objects and even create some of our own. So, since C++ derives from C, almost anything you write in C can be compiled in C++. It's basically that line that we looked at earlier. This line of code is from C, but if we have an integer variable named myvar equals var2 plus var plus 6, this statement right here is actually valid in C++ as well. Okay, so first thing is, once you have Visual Studio downloaded, this says Visual Studio 2010, but really I want you to download 2012. Since I'm using 2010 today, I just put 2010 here, but the steps are almost identical, essentially identical. So you start at Visual Studio 2010, then you go to File, New, Project. Then we're going to ensure that we have Win32 console application selected, and that we're under the C++ programming language, because when you install Visual Studio, you might have multiple languages installed, such as C# or Visual Basic, etc. We're going to give the project a useful name and press OK. And then under Application Settings, we're going to verify that we have Empty Project checked. Click Finish. Okay, so that's the first part. That's to create a project, so we'll do that right now. Under here, we're going to go to File, New, Project. This is identical in Visual Studio 2012. Click that. and then you get the new project dialog. Notice it's currently under VB because that was probably the language I was using last. I want to make sure I'm under Visual C++. Okay, make sure you're under Visual C++, that you have Win32 console application selected, and here's the part that a lot of you guys will skip, especially if you're new. Don't skip it. I want you to make sure that you give it a useful name, such as, we'll call this Session 1 Code. Alright, and under Location, by default it's going to put it somewhere under the Visual Studio Projects, under My Documents. That's acceptable as long as you know where it is. But I would recommend clicking Browse and going to a particular location, that you want to put the code in. So under the workdir, actually I got to go to the right workdir. Okay, summer. So I've got summer, and then I've got this file called workdir. I just like to keep things organized. So I'm going to put it under the summer 2013 CIS 225 workdir. Workdir is a very common thing to call the working directory where you keep your programming projects. Okay, so I'll call this project's, or the solution's name. Project's name is Session 1 Code, and then you click OK. So then you click Application Settings, and this is the part you cannot skip. You have to check Empty Project. Verify that it's on console application, and check Empty Project. Click Finish. Once you've done that, you'll notice that the solution is created, and so you know some of the terms here. When you create a new project, basically in Visual Studio, a solution is a collection of one or more projects, and the projects are collections of your source code, which is what you'll be coding, and also some resources and other things like DLL files and other resources. So, but for our purposes, we can think of a project as a collection of our source code and solutions as collections of projects. For our purposes, we'll generally have one solution which contains one project, and then that may contain one or more source code files. Okay, so the next thing this instruction says is to right-click source files and go to Add New Item, select C++ file, which is .cpp, and name it something appropriate, such as main.cpp, and click Add. Note that the file we created is the source file. This is where the source code will go. So let's do that. We're going to right-click Source Files, go to Add, New Item, and we're going to verify that C++ file is selected. And then we're going to give it a useful name. In my case, I'm just going to put main.cpp, and click Add. Okay. Now, it will pop up. This is the source file, main.cpp. It's completely empty when we start. But our first program, we're just going to do what's called the obligatory Hello World application. It basically just, we print something basic to the screen. And what we're going to do here is you're going to type in the code, include IOStream using namespace std for standard, and then I'll type this code. Okay, this right here is a very basic skeleton application. It doesn't do anything. If we ran it right now, it would not do anything yet. But right here, include IOStream. This is so we can, IOStream is a library that we're including. This is so that we can interact with the console and actually do input and output to the console. So input from the keyboard, output to the console, which is like a black screen that will pop up. We'll see it in a second. Using namespace standard, again, these two are in some ways quite intricate and complex, but for right now we'll just say that this statement using namespace standard keeps it so that we don't have to type as much when we start using variable names. So right here, I want to print something to the console. So to print something to the console, I type cout. That means console output. Then you do two less than signs. That's called the stream insertion operator. Okay, I know big words. You can impress your family and friends. And you're going to say, hello world, my name is John, or whatever your name is. and then I'm going to close those in double quotes. That means it's what we call a string literal. That means anytime we want to type a bunch of text or print a bunch of text out to the console or what have you, or manipulate a bunch of text, we put it in double quotes on either side. Cout, again, stream insertion operator, then the string literal, then another set of the stream insertion operator, and then the variable named endl. Now this variable and also the cout variable come from IOStream. We did not define these variables. Endl basically means end line, and what this is for is that it allows us to add a new line character. So I'm going to go to build solution, then debug. After it's done building, you should see a it's taking a little while. Okay, so it says 1 succeeded. That's what you should see. If you have a syntax error, for example, if you're missing the semicolon at the end, or you're missing one of these, or you're missing a double quote, or there could be a bunch of different things that go wrong. I mean, you have to fix it if there's an error. It'll tell you it failed, and it'll generally tell you something about the error. For example, if I take off the semicolon and I go to build, it'll say it failed. And if I scroll up a little bit or look up, it says that there's this error, and it says syntax error, missing semicolon before return. If I double click that error, in this case it actually points to about where the error is. It says return is confused because you didn't end a semicolon somewhere before return. So we look up and we say, oh, there it is, I missed my semicolon. So now the underline goes away and everything's hunky-dory. So we build it, and what this does is it takes our code and it turns it into machine code. That's what a compiler does. It compiles it. It also links in any libraries. That's why we call Visual Studio collectively an integrated development environment. It's not just the compiler. It's the compiler, linker, loader, and debugger, which we'll talk about debugging in later sessions. So main is what we call the entry point of our program. Whatever occurs in main is what will actually happen in the program. So as soon as I execute this program or cause this program to run in memory, main will be the first thing that gets pulled into memory. So whatever happens in main is what the program does. So I now, after building it, I go to debug, and I'm going to do start without debugging, and you'll note now that it brings up a console, and you can ignore the press any key to continue. That's actually put in there by Visual Studio itself, because it causes a pause to occur so we can see what our code does. But you'll notice that everything I typed here, hello world, my name is John, is now printing to the console because we said console out. Now notice this endl here causes the insertion point to go to the next line. If we leave the endl out, notice what happens. If we just take that whole thing out and the additional stream insertion operator, we build and then debug again, start without debugging. Notice that it prints our code, or it prints our string here, but it does not put the press any key to continue on the next line. That's why we put an endl. Right, end line. Okay, so I didn't go through the exact stuff here, but it's pretty much the same thing. Another thing you might want to do is declare numbers and use them. So the most simple number that we'll deal with are called integers. If you remember from your mathematics, an integer is basically the counting numbers and their opposites. It's a whole number, so it doesn't have a decimal portion. So a variable, again, is like a storage unit that holds a value. So we can declare variables by saying they're the type of data or the data type of the variable, and then give it a name. It has to be a valid identifier, which again we'll get into more details later, but we'll call this one num1. And I'm going to say that equals 10. All right. Notice I put a semicolon at the end of each statement. Then I have num2 is equal to 20. All right. So what I'm saying here is this variable is an integer, and then that variable is an integer. This first variable has the value 10 in it. The second variable, num2, has the value 20 in it. And let's say I want a final variable. I can do this on separate lines if I want to. It's a final equals num1 plus num2. All right. And then I'm going to delete my hello world statement here. I'm going to say the total is, and then I'll type final, and else. So notice I can put more than just string literals in a cout statement. I can, as long as I separate them by the stream insertion operators, every time I'm breaking to a new variable or a new string literal, I can put the variable name here, and it's going to print the total here. So what should it print out? Let's look here. Here, the plus symbol means integer addition. So it takes the first value, 10, adds the 20 to it. The result is 30. It takes that 30 and stuffs it in final. So this variable now contains the value 30. So this should print out the total is 30. Let's build it and see what happens. Alright, so when I run it, it says the total is 30. Not surprising. Now, if I want to get input from the user, I can use something from our IO stream. We already saw cout and how we can output to the monitor, to the console, but in this case I'm going to use a statement called cin. So let's see, instead of using, let's say, num2, I'm going to just set num2 equal to 0 as a default value. And then I'm going to say, right here, I'm going to say, please enter a number to add to 10. Then I'm going to take in input. Notice that we now have two greater than signs instead of less than signs. With cout, the two less than signs are called the stream insertion operator because we're inserting data from the computer to the outside world into the console, right? Until you're making calculations, your program's doing stuff, and it's sending it to the console. To get information from the outside world, in other words, in this case, the standard input device, which is the keyboard, we use cin, which means console input, okay? And this right here is called the stream extraction operator. Stream extraction operator. We're inserting the data, whatever we get from keyboard, whatever the user types, is going to be put into num2. Okay, so we're going to build this, and then we're going to run it. Then I'm going to put, let's say, the number 50, and I hit enter, and then it says the total is 60. Because what it did is it took my number that I entered, number 2, and it added it to the number that we already have here, which is 10. Let's run the code again. This time I'm going to put 150. I hit enter, and it says the total is 160. Quick as that. Calculates it for us. So it's basically built-in calculations for us. All right, the center of programming is performing calculations and logic. So the next thing we can do is, in C++, we have the option to use what are called conditional statements. This is where a lot of the power of computer programming comes from. Now, we're not doing a heavy treatment of it just yet. We will do that when we get into control structures later on, but I'm just giving you kind of a bird's eye view of some of the stuff you can do. So, in this case, let's see if I can copy and paste it just to be lazy here. I'm going to a handy thing you can do in C++ is you can highlight code and then just hit tab and it tabs it over. So I'm going to change the format a little bit here and make it a little bit prettier. Okay, alright. So this is our code. I have a variable an integer variable named age, that's its name or its identifier of the variable, and I set it to the value 0. I prompt the user and say, what's your age? And then they enter the age. Then I use an if-else statement. Okay, so this structure says if the age is greater than or equal to 21, I'm going to print out, here, have a beer. Otherwise, that's what else means, I'm going to say, here's a soda pop. So let's see what happens. I build it. I start without debugging. It says, what is your age? I'm going to enter 15. It says, here's a soda pop. Okay, so it made a decision based on the input. This is the fundamental this is one of the fundamental control structures within a high-level imperative language, is the decision or selection control structure, which we'll again get into more deeply But basically, this is really cool. We already have written a program that can make decisions. All right. So, and in some areas of artificial intelligence, this is also the fundamentals of artificial intelligence. Also, it's also very heavily used in video games. For example, if I hit the in some games it's up arrow, down arrow, left, right. In other games it's WASD. Your controller for your Xbox or what have you. Whenever you hit any of the controls on there, none of this is happening by magic. A lot of this involves if statements or selection structures. It'll say, if they hit the up arrow, do this, move the character up. If they hit the down arrow, do this, etc. Okay, so it's used in pretty much every aspect of code, of programming. So I'm going to start again. This time I'm going to put 22 is the age, and it says, here, have a beer. All right. So that's the basics of decisions. So when you run this code and try two different values, you'll notice that it gives different output depending on what your input was. Okay. So basically, in summary, what we've done is that we've learned how to declare an integer variable. We've learned how to, using the IOStream cout and cin variables and the stream insertion and stream extraction operators, we've learned how to print stuff to the console and obtain data from the user. And we've also learned how to make decisions. Okay, and another quick note is at the end of code, you put the return 0 statement at the end of the main function. Don't worry too much about what that does right now. It basically just tells us, or tells the operating system, hey, I'm done now, and everything went hunky-dory. Everything's good. No errors. Okay, so that's basically what we're doing today. It's a pretty short lecture today. If you have any questions, please feel free to email me. Again, it's jpbaugh@oaklandcc.edu. And I hope we have a great semester. And don't forget to go to the discussion board and to upload your information. Also upload a new picture. Not upload, but write your post down with an introduction to yourself, and also upload a new picture or a picture if you don't have one already. By next week, you should try to get Visual Studio 2012. I say next week, but what I really mean is the week of the 13th. You should have Visual Studio 2012 downloaded. If you have any trouble downloading it, please contact me. Please ask me for help. We'll try to make sure that you can get a copy of that. So again, if you have any questions, put them on the discussion board or email me. And I appreciate it, and I hope we have a great semester. Thank you very much.